Yes. All right, so we're circling back to Advent of Code 2022, day 16, now that we completed day 17. It is called Proboscidea Volcanium. The sensors have led you to the origin of the distress signal, yet another handheld device, just like the one the elves gave you. However, you don't see any elves around. Instead, the device is surrounded by elephants. They must have gotten lost in these tunnels, and one of the elephants apparently figured out how to turn on the distress signal. The ground rumbles again, much stronger this time. What kind of cave is this exactly? You scan the cave with your handheld device. It reports a mostly igneous rock, some ash, pockets of pressurized gas, magma. This isn't just a cave, it's a volcano. Yeah, I kind of knew that based on doing 17 first. Oops. And I knew there were elephants coming, so... well, spoilers. You need to get the elephants out of here quickly. Your device estimates that you have 30 minutes before the volcano erupts, so you don't have time to go back out the way you came in. You scan the cave for other options and discover a network of pipes and pressure release valves. You aren't sure how such a system got into a volcano, but you don't have time to complain. Your device produces a report. Your puzzle input. Let's get our puzzle input. 122, day 16. That's not too bad. All right, I don't want to get a false sense of security here. Each valve's flow rate, and if it were opened, and the tunnels you could use to move between the valves. Okay. There's even a valve in the room you and the elephants are currently standing in, labeled AA. So there should be an AA here. Oh, it's 57 lines. Oops. So there's a lot of them. Correct. AA in input. All right, there it is. You estimate it will take you 1 minute to open a single valve and 1 minute to follow any tunnel from one valve to another. What's the most pressure you could release? For example, suppose you had the following scan output. All right, this is our test input. Okay. All the valves begin closed. You start with valve AA, but it must be damaged or jammed. So something, its flow rate is 0. So there's no point in opening it. However, you could spend 1 minute moving to valve BB and another minute opening it. Doing so would release pressure during the remaining 28 minutes at a flow rate of 13, so you get automatic calculation of 364. So every time you open a valve, you can just add in okay. Because you used up 2 minutes, you only have 28 minutes left. That means you have 30 minutes. Oh, yeah, I read it, but I forgot it already. Okay, there it is. All right, then you spend your 3rd minute moving to valve CC, your 4th minute opening it, providing an additional 26, so 52 total. Making your way through the tunnels like this, you could probably open many or all of the valves by the time 30 minutes have elapsed. Okay, so my first thought is breadth first search, right? Where we just work our way through all the valves and eventually opening all of them. It looks like at this point here, you've opened all the valves. And so you're just now waiting. And there's the final total of 1651 for the test input. All right. But I'm guessing because there's a lot of zeros here. Grep. There's a lot of zeros in the test input too. Grep-v rate equals 0 semicolon in our test input. Oh, okay. So there aren't that many tunnels that have, so even though there's 57 valves, there's only a few, 15, that have valves worth opening. Okay. I wonder if there's something we can do about that. I don't know yet. All right, let's put 16 in here since we didn't do 16 before. We did 17. I do need to put day 16 last here so my runner, my solution grabs the last one correctly and I don't have to edit that code. All right, so this should go back to unknown unknown. Oh, as soon as we create it, the file, right? There we go. All right, so I guess the first step would be parsing, right? So let's create a valve. Well, these are tunnels, right? So each one of these is a you can follow any tunnel from one valve to another. So I guess it's a valve. Let's call it a valve. And the valve has a name, a flow rate, and then a list of other valves that it connects to. Let's call them paths to valve. And then we can just parse those. Our input is going to be our tunnel. Which is also a Vecca valve. All right. So let's see how we can parse this. Let's move this over a little bit so we have the full information. Let lines equals AOC lib, read lines, test input dot text. First thing we'll do is we can split on, I guess, the semicolon. Right? And then that would give us a number, or we can split on, yeah, and then we can split on the equal. So we can say let VT is equal to, for line in lines first. Line dot split once, semi, unwrap. And now V is going to be valve something has flow rate equals something. We can let vname rate equals v dot split once on equals. Okay. I'm still hesitating because this is a little awkward. Let name is equal to vname dot split on space dot skip one dot take one dot unwrap. Unknown. Vname is unknown. Oh. That's still unknown. Okay. Println name. Did I get that right? Nope. It doesn't know how to unwrap. Oh, next. I keep forgetting. Take one. In fact, we don't need to do the take one then. Right? We can just do the next. Oops. Like that. All right. So I see down here. There it is. So we got all those. And now we need the flow rates. Rate. We can throw that on there as well. Zero, 13, 2. Okay, so those are all working. And now we just need this list here. Blah. So that's the T side of things. I'm going to add debug to this. Derive. Debug. So that we can print them all out at the end. Println debug out self tunnels. This Ayush, thank you for the follow. Much appreciated. Welcome to the stream. So 1, 2, 3, 4. Oh, that's frustrating. If there's only one valve, it doesn't put an S on the end. I just want to grab the list and then do a split on the list. Can we do it this way? We can say t.strip prefix tunnels lead to valve. Oh, no, we can't. Because this tunnel leads to valve and leads to valve. Oh boy. This is, I hope this, that, how about this? How about this? We can say let paths is equal to t.split on comma space, and then the first one we can just ignore. I mean, not ignore, but handle separately. Split, not split, collect into a vec of stir. There we go. Because I don't think it matters what order the paths show up in, and then what we can do is say let first is equal to paths of 0 dot split on space last unwrap. And then we can say self tunnels. Oh. We'll call this all paths, because then we can just say let paths is equal to vec new. How about vec bang first? And then paths extend all paths. And then self tunnels push. And we're going to create a new tunnel. So we have the name. Oh, valve. Name is going to be the name, the string. Flow rate is going to be rate parse unwrap. And then the paths is just paths. Is that it? All right, let's see what blows up. Oh, to string. Iter map s2 string. There. Still doesn't like it. Oh, these are vec of, oh yeah, vec of string. And let's see what happens when we print them out. So it looks like it's working. All right. So valve A has flow rate 0. Oops. Oh, right. I forgot to strip this part off. The first one is a special case. We're going to say let first is equal to first dot split on space dot last dot unwrap. Iter, and then this has to be, oh. Why does it still have this? Okay, let me print out first. Println. I should make a macro that these two characters reverse because I mess it up all the time. Yeah, okay, so that's working. Oh, I know. I'll pass. I need to skip one. Right. DDIIBB, valve B. Okay, let me get rid of these prints here because I think we're there. We should be able to see it here, right? DDIIBB. Valve BB has flow rate 13, goes to CCAA. Valve C has flow rate 2, and paths go DDBB. Okay, and then JJ has 21 and a path to II. Okay. All right. Now, I think it's basically a breadth first search, but this is going to be a lot. Right, there's 10 different valves, which means we have 2 to the 10 states, but the other one's 15, right? The real input's 2 to the 15 states, right? Because each valve can be on or off. We also need to know the current location, and we need to know how much time is left. So there's 30. I'm just trying to figure out how many states there could be. So it's 30 times 2 to the, I don't know. How do you do exp? Self tunnels len. So it's 30, each one can have 30 minutes by that. And then you can have, it's not seeming like there's a lot of state, but maybe I'm missing something about the state. Because because we have 10 here, so 2 to the 10th is 1024, right? 2 to the 15th is 32K. So I think, like I said, breadth first search, but we need to figure out this important state information. So let's come up with the state information. This is just me walking through the tunnel. So I'm just going to call it good old walk. And walk will have a location, which is a string. It'll have the remaining time, which is usize. That way we will know we have a bug. If we ever go negative, it'll panic on us. And then we need to keep track of which valves we visited. I guess we could just do that with a hash set for now. Right, and this is going to be, okay, we're gonna have to go get fancy with this, because if this is our state, hash sets don't hash. We're gonna have to write a custom hasher for it. Because here's what I'm thinking is we'll come up with a I'll call it the search, and just put a scene in here, and this just to be a hash map of walk to usize. And what this is going to do is this maps current state with our max flow, our flow so far. Right? So that way, if we ever do a breadth first search and we've seen a state already, we know how much, we know what the answer is from that state. So hopefully that'll help reduce the amount of time it takes. And in order to hash on walk, we're going to have to write a custom hash routine. Because if I just do this now, it'll complain. Well, first it'll complain that hash map and hash set don't exist. No code actions available. Oh, because I've messed up this thing here. Let me get rid of this println. We don't need it anymore. Hash set doesn't exist. Hash map. And now if we try to build it, it'll say that this is not hashable. So we're going to have to do that. Walk is never constructed, search is never constructed. Oh, maybe it doesn't mind. Or maybe because it's not constructing it. Let's find out. So let's call the search, let mut search equals search new. Impulse search. New. Self. Actually, we don't need it, right? We can just do we are going to implement something on search at some point, though. Okay. Scene is never used. Okay, so, and then our walker is basically walk of the current name, which is going to just be our starting point. The flow rate that we've gotten so far. Oops, I guess we have to put the things on here. Name, and then flow rate, and then the, oh, no, it's this here. I was looking at the wrong struct. Loc, remaining time, which is 30, and then visited, which is hash set new. And now we'll just we'll call search BFS on walker. Oh, and then we'll have to give it the cave system, which is just self tunnels. And we'll write that impl. I'm just going to have it return 0 for now. Search fnbfs mut self, because we want to be able to update the scene hash map. Walk is our walker is going to be walk. Let me be consistent with the name. And then our tunnels is going to just be, oh, I'm trying to think. What we're going to need to do is look up in the tunnels. We're going to need a hash set instead, which describes from a given valve. Yeah, this is going to have to be a hash map from a given location to a valve. So instead of tunnels push valve, we're going to say tunnels push, and you can say insert name to string. And then maybe we don't need to store the name in the valve also. Oh, this is going to blow up because I never finished my BFS. So, but this is what this is going to have to be. It's going to be a hash map of string to valve. And it's going to return a usize, and it's just going to return 0 for now. Okay. I think this is the structure we need. I got an extra thing there. This should be hash set new with the lowercase n. Right. Okay. This is compiling though. That's good. With just some warnings. All right. So the first thing we want to do is, in breadth first search, is if we've seen our current location already, if we've seen it, then return it. Otherwise, we're going to return 0. Yeah, okay, so this is where it blows up. So it only blows up when you actually try to call get, or probably insert would also fail, right? Okay, so now we have to do this on Walker. We have to implement EQ and hash. So we can, I think you have to implement partial EQ. I think that's what you do, impl for walk. right? And it'll tell me, if I try to build now, it'll tell me what the function signature is. Missing the EQ implementation. And I can just go down here, copy, paste, delete this, and delete that, and put that there. Do a quick reformat, do other, and then this is self. I don't know why I put RHS here. It should default to self, but okay. So for them to be equal, we have to say self lock equals other lock, and self remaining time is equal to other remaining time, and our visited sets are equal. Can you compare sets that way? Visited, self visited is equal to other. I think you can. So that should be partial equal. And then I think equal is just a marker. Yeah, and now we just have to write hash. And I always forget how to do that. RG hash. So we have an example here. Okay, let's just grab that and put it in here, and then we'll just edit it. Oh, I don't know why I typed O. Okay, let's get rid of this for walk. Do you have to do it that way, or can you just say hasher like that? Okay, and then it's self lock hash, self remaining time hash. And now this is where the tricky part is, why you can't hash sets. You actually have to figure out what you're doing with them. So let mut vec is equal to self visited iter collect vec of string. Can I do it as a reference to strings so I don't make clones of them? And then vec.sort. And now for v in vec, self, v dot hash state. That's interesting. That's a shame that this code action won't automatically action itself. Use standard hash. Oh, and write hasher. Okay, let's try this. See, now it accepts it. All right, let's try building. Cravo, hello. Cravo says, yo, Uncle Scientist, just passing by to say Rust is wonderful. Okay. I'm a C coder too, so I can't disagree that Rust is a fun language to use. You're not wrong, is what I'm saying. All right, bug on 105, or a compiler issue on 105. All right, so I think we're now at the point where we can write a breadth first search, but it's tricky, right? Because we have these valves that we need to turn on. So we have to say, as part of our search, we first want to determine whether or not we can turn on the current valve that we're in. So if walk visited contains walk lock. If we haven't visited this particular, visited means turned on. Maybe I should call it that, just to be make the naming work. Turned on. Okay, if we have not turned on the current valve, then we want to try turning it on. So turned on equals walk turned on. We're going to be doing a lot of cloning, unfortunately. That's probably going to make this solution very slow. Dang it. Turned on dot insert walk. clone. Got to clone that as well. And now we want to call BFS again. Oh, we need to keep track of our current max. Let max flow equals 0. So then we say max flow is equal to max flow dot max of BFS of our new walker, which we haven't invented yet. We got to create one with the new state, which is going to be our current location. It'd be nice to be able to make those references instead, right? Not like we're just copying the references. Remaining time is going to be walk. It takes a minute to turn on. -1 for the remaining time. And then our new turned on struct. And then we're just going to copy the tunnels. Now this is just a reference, so that shouldn't be a problem. We don't need to clone it. And what we need the tunnels for is for the next part of the breadth first search, because now that we've taken care of turning on the valve, now we have to see where else can we go. We're going to go through the list of entries, so we can create our dest tunnels dot get walk lock unwrap. And then this should be the valves that we can visit. And the valves, the valves contain the room name. So we can say for, no. The valve contains the flow rate. Okay, good. And but it doesn't contain. Oh, right. So even before we do this, we have to determine what our current flow is, because it's the breadth first search of this plus the amount of flow we get from turning this valve on. And that is from the tunnel. The valve of that guy, get walk lock dot unwrap dot flow rate times how much time is remaining, which is walk dot remaining time -1, because we turned it on and we had 28 minutes left, right? So that was that. So we have to subtract 1 from the time. So this is this plus flow. Okay, so for valve in dest, this is a valve. Oh. Paths. Right? Okay, now it's a vector string. Okay, and now we have the string of where we're going to go to. So we can just say max flow is equal to max flow dot max of BFS of moving to a new location with remaining time of walk dot remaining time -1 and an unchanged visited turn on this walk turned on dot clone, right? And we're not adding any additional flow on that one. And then we're going to just say self-scene dot insert walk dot clone max flow, and then we're going to just return the max flow. Okay, let's see if that compiles. Oh, tunnels. And then this should be self BFS, right? As should the other one. Walk does not have this field. Oh, I called it visited again, didn't I? Turn on. And that's the self one, that's that one. This needs to be ampersanded. Okay, let me see why that one failed. Come on. Oh, is it running? Maybe it's running now. So we have 0 errors and 0 warnings. Okay, cargo, run, release. Oh no, it's blocking waiting for file lock on package cache. Oops. Let me just go over to my other screen here, create a new login window and take a look. ps-ef grep target. Yeah, there's a cargo check running. Let me kill that. There we go. All right, so let's try again. Oh no! Maybe killing it left a file left over? Let's go find out. Let's look for this. I bet you there's a file I need to delete. I remember having to do that before. Yeah, see, I even used this link. Cargo clean. I can try that, but I don't think... No, that worked. Okay. I thought there was a no, see, it still says there's a block. Okay. So obviously that didn't help. Here it is. Here it is. Dot package cache. Okay. There we go. Cargo clean. Cargo build. Okay. Switch back there. Switch over here. Switch over here. And now... Oh. Okay. I'm going to quit out of that just in case that there was something going on there when I killed the cargo check. Oops, I don't want that. I want this one. Yeah. All right. 130. It's saying an argument is missing. Oh, yeah, I got to add the tunnels to it. Okay. And then walk clone for expected walk found a walk. Oh, okay, I know why. Even though we're cloning walk, it's a reference when we're making a clone of it. We're just cloning the reference because this is a thing you know what to do when you... There we go. Okay, now we have a move. Can I do that? All right, what's the warning? We're not using the name of the valve yet. Okay. That's okay. Okay, so cargo, run, release. Now this is the test input. So hopefully it'll complete quickly and let us know if we're on the right track. Oops. And it was 16 something, 1651. This is why I don't build release, unless I absolutely have to. Ooh, it failed. Stack overflow. Oh dear, oh dear, oh dear. Okay, so that's presenting a problem. Let's take a look at our breadth first search and find out why we might have a stack overflow. I mean, the remaining time should be going down, right? Each time we create a walk, we're creating a walk with one fewer. So the most it should, the depthiest it should be is 30. Let's just do some prints up here. Print. Walk remaining time. And it should never go negative, right? Because it'll blow up with a or Rust will panic. It's going negative. Oh, because I'm running release. Oh, you know what? Yeah. Let's try. If I just did a cargo run without the release, then it would blow up. Gotcha. We need to make sure that we have enough time left. Walk remaining time is greater than 0. And we have to do that here. Oh, I guess if walk remaining time is equal to 0, we can just return 0 right away. If walk.remaining time is equal to 0, return 0. I was thinking, well, let's put it in the cache, but there's no reason to put it in the cache because it's just going to exit right there. Okay. All right, so hopefully that will stop the thing from dying. It's slow, but it came up with the right answer. As I was starting to say it's slow, then the thing printed the answer and it came up with the right answer. All right, well, let's see. Let's see if we can use our input and to see if this is unbearably slow. (2022-16). All right. I'll let it run for about 10 seconds in debug mode, and then if it doesn't come up with an answer by then, well, we can switch over to release. Is that about 10 seconds? Shall I give up? I'm going to give up. Release. One of the things I'm thinking of is that there's certain places that you don't need to walk to. You can just walk directly to the place you want to go, right? Yeah. Okay. Like, you don't have to go to FF, right? From EE, you turn this valve on, and then you can just skip over FF and go straight to straight to HH, right? So you can just go those 2 steps and get there. And just say, well, it took me 2 minutes to get there instead of always taking 1 minute. Which means I'm going to have to rework the input. Yeah, this is taking forever. All right, while that's happening, let's take a look at what it would take to build a set of paths from AA. How many steps does it take to get to DD? You know what? It'd be nice if I actually if I drew this out on a piece of paper. But in order to get to JJ, for example, from AA, you have to go through II, JJ. Right? So you go from here to here. From here to here. That's 1 move. And then from here to here, and that's 2 moves, 2 minutes, essentially. So if we could just keep track of all that information, that might be enough to speed things up. So why don't we look at that? We have the walk, we have the valve. Let's implement valve. Oh, no. We want to implement it on Yeah, maybe we just create a function which takes in the names of all of the, so we can take the tunnels and convert the tunnels over. So we can say tunnels to paths, shortcuts. Let's just call it shortcuts. And this is the tunnels, which is a vec of string to val. So we should be able to figure out this, and it just returns a hash map of string to usize, which is the distances from each tunnel to each other tunnel. And then we have to call it O. Okay. Hash map of string to a hash map of string to usize. All right, that way we have the starting one, and then for each ending one we have a distance it needs to go. Okay. So we have to do a exhaustive search. Or a depth first search. Scene, insert. What's our starting point? Let's just use the references, and then Q, push back, and we'll just do start and 0 like that, and then you say while let some node and distance is equal to Q pop front. Okay, so now we have to loop over each exit for that valve. So we can say for, and we have the valve exits, we can look it up. Let v is equal to tunnels.get node unwrap. That's an unknown, but I inserted this here, right? This is a string in here, and an I32 usize. Let's keep everything at usize. So this should pop off. Oh, because I don't have vecdeck yet. Really? There it is. If you move off of it, then it says no code actions. Oh. Okay, let's just do that for now. And it doesn't like this. Oh, because it doesn't know what type it is yet. Okay, we'll get there. Okay. Now that's a string and that's a usize. Perfect. Okay, so now we know what tunnels. Oh. Ah, dang it. Yeah. That's right. That's right. Because the valve has a list of destinations. And we just need to, what we're trying to calculate is the cost of getting to that destination. So the first thing we'll do is for v in, path in v.paths, right? There. If not seen, insert path, continue. Right. So this is Rust's kind of clever way of, if we insert it into the hash set and it returns false, it means it was already in the hash set. So we don't have to do if it contains it, and we don't have to say if seen contains path, continue. Scene dot insert path. Right. This line, these two statements, which end three statements end up on a bunch of lines, can all be consolidated into this, which is nice. So now we need to know if the room that we're looking at has a flow rate. So let room is equal to, I want to get again from here. And it's not node, now it's path. And if room.flow rate is greater than 0, and room.name is not equal to start, right? Because we don't want to, if we loop back to ourselves, we don't want to keep going. And I'll fix the underscore thing in a second. Then we want to look in our paths hash map. This is where paths comes in. Because if it's already in our paths list, then we want to see if we have a shorter path to it, and if so, we're going to insert that. A better path to it. Or do we just insert it? Let's try just inserting it and see what happens. So we can say paths.insert room.name.clone with our current distance, which is here, +1. Right, and then after that, we're going to say q.pushback can we do this? Room. I might have to dot it. Name dot dist +1. And then just this becomes paths. This is still running in release mode. Wow. What are we comparing string with ampersand string? I guess we could do that. And that. And this doesn't like this because it was expecting one thing and it got something else. Yeah, if we do it for one at a time, we can do it this way. Okay, now we got 2 warnings, but we can try printing that out. I'm going to just create a new tab here so we can. Oh shoot! It's not the same font name. Dev amclib. I don't want to run it yet. So I'm going to comment this line out for now and just put unsolved. But I want to do is find to get the shortcuts, call the shortcuts code for each one of these things. All right, so we can look at each valve in our tunnels for v in self tunnels dot keys. It's a string. Println v shortcuts are debug out shortcuts from v tunnels. Self tunnels? Something like that? Okay, let's try running. Oh, yeah, let's switch back to the test input. But it looks like it worked. I have no idea if it did, but it looks like it worked. Let's move this over here. So AA can go to BB in 1 step, right? JJ in 2 steps. That's what we talked about before. DD in 1 step, CC in 2 steps. So I can go to DD and then CC, right? EE in 2 steps. DD. Uh-oh. Is this wrong? It's saying we can go to EE in 2 steps. Oh yeah, DD, and then from DD to EE. Okay, yep. And then HH in 5 steps. I don't know if I'll be able to do that in my head. So go to GG is 1 step. Go to FF is 1 step. Go to EE is 1 step. That's 3 steps so far. Go to DD, that's 4 steps. And then go to AA, that's 5 steps. Okay. So I think these shortcuts are working. And this is still not done. It is single threaded, but still. Let's see if we can use this in our BFS code now. We can change right over here. Okay. We have to change the way we do this part here and look up the cost of going from one state to the next state. And instead of going this tunnels get paths, we want to look up these shortcuts. And I don't want to compute the shortcuts each time, right? So I actually want to save the shortcuts in our... We might need them for part 2. This is the hash map. String to hash map of string to new size. And these are the costs to get from this location to this location. Costs this much. And that way we can look it up. And what we'll do is in here, after we're done parsing, we can calculate all those. So that'll be part of the parser. And we can just say self shortcuts of v.clone, and then we'll just call shortcuts. Dot insert. Come on. There we go. Yeah, it just took a while to build because I think the CPU is overheating on that one. Okay. So now what we need to do is pass that down into our BFS. So we can look it up each time. All right, this stays the same because we're trying to see if we can turn on the current, the one where we are now. The dest now becomes this, and instead of just blindly going to whatever paths are there, we want to look up in the shortcuts where we can go. So here we go. Shortcuts is hash map of our from location, hash map to our destination with a cost of that much. And it's going to be ampersand. It doesn't like this because why? Did I make another change that I forgot to finish? No? Let's see why it doesn't like it. Oh, is it all because of that? I'm going to go back over to Clippy here because I don't want to run it just yet. Oh, I see, because I'm doing that thing. Whoa, things are slow. Things are very slow. I'm going to quit out of bacon. I think this, I'm going to kill this because this is probably just taking up too much memory at this point, and it's making everything go slow. So let's go back over here since it's a larger font. Cargo build, what was the problem? Oh, right. Each one of these needs to get passed in that thing as well, right? Ah, that was the only problem. Okay. Cargo, run, release. Oh, yeah, we're going to do it on the test input. We're on the test input. Okay, so it should still be 1651. So I don't know how much of my stream got disrupted by the fact that I was running out of memory. Hopefully not too much. Oh, right. I actually have to print out the answer. $16.51. Okay. So now we're using the shortcuts, except we're not. We need to be actually looking at the shortcuts that we're passing around. So for v and dest, now we need to get the cost. Let cost is equal to, let lookup is equal to shortcuts dot get walk. Unwrap. Okay, and that's our hash map of our costs to our, so now for each, yeah, we can put this here. It doesn't need to be in the loop. And then cost is going to be lookup dot get v dot unwrap, and that should be our use size of that, and then we just subtract cost. Oh, but we don't want to go negative. If walk dot remaining cost, sorry, cost is less than walk dot remaining time, then we can do this. Otherwise, we will run out of time and we'll go negative. All right, let's see if this solved. So that took 768 to solve. Let's see if this does any better. Let's see if it even is correct. Of course not. Called unwrap on an unknown value on 177. That's right here. Oh, it's saying that you can't get there from here. Yeah. If let sum cost is equal to this, else println tried to look up v in lookup. Now let's see what I got wrong. Oh, I gotta debug that. Oh, where are we then? Right, we're at walk lock, and we're getting all the shortcuts to walk lock. And then V should have, what's dest? Is dest just a list of strings? Yeah, it's just a vec of strings. So let's change this to this. That way I can look at what dest is. Okay, do it this way. Because that'll have the name of the source valve. So we're at DD, and we can go to CCAA or EE. So we want to look at the cost of going from DD to CC. Oh. Right, and that's what the shortcut should have. The shortcut should show that DD, but it's saying these desks are EE, CC, JJ, HH, and BB. Oh, right. So what? And then just going to those guys, right? Because this will tell us the cost. Yeah, let's do that. Let's say dest and cost in shortcuts get walk lock unwrap. Right, and then this will be this. Oh, isn't this a okay? Let's see what this is. Yeah, I thought it would be this. Oh, maybe not it unwrap. Iter? Can I do this now? Cost? Let's see what happens. We should be able to walk the destinations here, basically. Expected struct hash map found tuple. Right, it is a hash map, and that's why I was trying to do an iter on it. My brain is starting to die here. Right, okay, so it's a hash map of string usize, and if I say iter, and now it's, I can't iterate the hash map key values. What am I missing? Rust, hash map, iter key value pairs. Pairs? Pairs. What? All right. Let map equals shortcuts get walk lock. We'll do that. Unwrap. And do that. And now can I say for dest cost in map? Ah, now I can. And now it builds. Okay, now we'll run this, and this again, this is test input. So hopefully it'll be 1651 without panicking. It is, and it did solve it a lot faster, right? 63 as opposed to 768. So it's about 10 times faster. Let's try the real input and see if it blows up my my stream. This is the problem of running your code on the same machine that you're OBSing from. And unfortunately, I'm out of time. So, oh, it came up with an answer after 5 seconds. So it was obviously much better to do that using that little cost thing. I don't know if it's the right answer. Let's find out. It is the right answer. Okay. I don't have time for part 2, though. I don't know what part 2 is going to bring, but I don't have time for it. I'm going to peek. I'm going to peek what it is, and then I'm not going to feel bad tomorrow if I already know how to solve it. Bacon. Run. Oh, I didn't want to run. I want to Clippy. All right, let's just fix this Clippy thing here. 29. We don't use nth. Yes, nth. Okay. Let's make sure it's still 1376. Git status, git add source, git commit -m. 2022 day 16 part 1. All right. Yes, now I'm going to look at part 2, and if it's really, really bad, I'm going to not do it, because it's almost noon for me, and I got to stop at noon. I don't know how long it's going to take. I've already been streaming for 2.5 hours, which is a lot longer than I normally stream, and I can feel my voice going. So, but let's see. Part 2. You're worried that even with an optimal approach, the pressure release won't be enough. What if you got one of the elephants to help you? It would take you 4 minutes to teach an elephant how to open the right valves in the right order, leaving you with only 26 minutes to actually execute your plan. Would having 2 of you working together be better, even if it means having less time? Assume that you teach the elephant before opening any valves yourself, giving you both the same full 26 minutes. What? Yeah, I assume this is just okay, you move, the elephant moves, and blah, 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 blah. With the elephant helping after 26 minutes, the best you could do would release a total of 1707 pressure. Oh my God. How would you do this? Would you like alternate moves? Like you go and then the elephant goes and then no. I mean, I can think of a dumb way to solve it, but nothing smart. I mean, a dumb way to solve it would be to just have it kick off. Where is it? In here, in the breadth first search. You could just like, I don't know, have a helper. And then if, instead of setting max flow to 0 here, you just kick off a helper. If helper, else 0. I mean, this would be a dumb way to do it, right? And then just here, just say self BFS. And then this walk here would be the walker for again, we're cloning stuff. This is why my other thing ran out of memory. Remaining time would be walk remaining time, and then use the same turn on, clone, right? And then just pass in the tunnels and the shortcuts, and then say false for the helper. I have no idea if that would work. Oh, and then we're gonna have to pass in false everywhere else. Right? Oh, no, this would be the false one, but if we came through here, then we'd want to have the elephant help us here too. I have no idea if this would even... Well, it doesn't even compile. I can't turn on clone. Oh, walk turn. And this would be, for part 2, would be true. Oh, there. I'm just going to run it. Let's run it on the test input and see if we're... Okay. I mean, this would be super dumb, right? This would take for a year and a day. And I don't even know if the logic is right. 1651 still. So it wouldn't even... Yeah. What are we looking for? They put the answer in here. 1707. So that's not even working right. And it's because why? Oh, because we're flipping the thing back to true every time. This should be helper. Nope, it's still 1651. You think with that, oh no, oh, because it's part of the state. It's got to be part of the state. Whether or not we found it with the helper or without the helper matters. All right, helper bool, which means we have to modify this guy, self and self helper equals other helper. We have to hash it, self helper. My brain is fried. Hash state. Right? And then instead of passing it in like this, we'd have to make it in the walk. Helper false. Helper. Walk helper. Helper. Walk helper. What did I forget? Oh, I got to delete the extra parameter. Walk. We don't want the bool. Oh, we don't have it here. Okay, let's look for it up here. And what's going on here? Doesn't like. This needs the helper. Helper false for part 1. And helper true for part 2. And what's wrong with this one? Missing helper, it's right there. Maybe that was an old error. Yeah, it was an old error. Okay, one more try. Is it 1707? No, it isn't. Oh my God. Oh, no. Okay. Yeah, I can see one more problem. We don't want to start from the current location. If the helper is helping us, the helper is going to start from the beginning. All right. $1765. That's the wrong answer. Dang it. All right. I think CodeMonk says it's a lazy helper. Well, it's helping a little bit now that I fixed the helper. The helper was following me around and starting from where I was, and then that wasn't working. I honestly don't know. Honestly don't know. Let me fix all these underscore name things, since now we're using the name. That's wrong with Clippy. And you know what I'm going to do? I have to stop. Unfortunately, I don't know what the bug is. Why we got, we're closer, right? We got 1765. We're only off by 58. What if I run the real input and then subtract 58? Well, that... oh, God. All right. I don't know. I mean, this was kind of neat, right? Coming up with the shortcuts, that helped. This is a tough problem. I don't know how to make this helper work. And then, yeah, using the cost instead of going, yeah, using those shortcuts here helped for part 1. For part 2, I don't know, dang it. If we start the helper, because the helper can start at any time, right? Anytime. The helper doesn't have to start right away. And as you can see, there's a bunch of state at the end here, at least for this one, right? For the test input, where moving isn't going to help because everything's open now. All the valves are open. There's nothing left to do. So starting the helper a whole bunch of time in shouldn't matter. Yeah. I'm struggling with this one. This one is... This one's a beast. All right, so let's look at 16. And the good news is it panicked. Why did it panic here? On line 27. Okay, let's take a look. I didn't think I checked in panicking code, but apparently I did. Oh, I know why it's panicking, because I was running on the test input, and I don't have the test input anymore. 22_16. There we are. Yeah, let's get the test input back. Yeah, it's coming up with 1765, and the actual answer for part 2 is 1707. And the problem was we're trying to figure out how to get this elephant to help us. And somebody did tell me that I shouldn't be using remaining time. When the elephant starts, the elephant can start at any time, but has 26 minutes. The elephant can start from any state that you have, but should still be given 26 minutes. And I don't understand why that would be true, but I'm willing to give it a shot. I don't fully grasp, apparently, the code I wrote. Which is a weird thing to say. But why would 26 work here? If you've already used up a bunch of minutes, how does starting the elephant from 26 with the current state of the... Yeah, see, it's 1887, so... Right, how would giving the elephant full 26 work any better than? And I don't know how that would be true. All right, so we're going to just keep poking at this until we can figure it out. One thing that we're not doing, though, is... Oh, maybe it's this? Because if you're allowed to give the elephant 26 minutes from any point in time, you should be able to give him to him at 0 as well. Which means we probably want to go through and memoize it. Which means we don't want this line of code. Which means we have to check here, right? And walk remaining time is greater than 0. Because that's all that was preventing that from going negative. All right. I'm going to cargo run without release. It'll be slow, but at least it'll catch any subtraction errors we encounter. No, see, it's still 1887. All right. I mean, this is gonna kill me. I'm gonna keep beating my head against the. All right. So what I'm gonna do for YouTube is maybe break here and then do like a swirly thing and then come back when I've got it solved, so that YouTube isn't just 2 hours of me hitting my head against the wall. What I could change, what I could tweak, what can I poke at even, just to see what's going on. I mean, I can look here. If walk remaining time is greater than, I don't know, what would be a good number? 26. I don't want too much output. And print minute 26. Oh, minute this with max flow. We can just take a look at some of those. Maybe that'll help. Is there a 1707 in here at all? No, there isn't. Oh, wait. Why are these 2-bit? Why are these going to 30? For part 2. It shouldn't. Oh, maybe that's the bug. So the bug isn't in my code. The bug's in my code. When I start this up in part 2, I gave it 30. Ah, gee. 1707. Okay. Although that there's a lot more of that for part 2, isn't there? Okay. So this part 2 might take a while to run. Let me get rid of these output lines. We now have something that works. Let's see how long it takes. Cargo run in release mode. And then I'll switch this over to the real input. As soon as it's done building. All right. So it took 0.2 of a second for the test input. For the real input, let's see what happens. Oh, it finished. That only took 5 minutes. 1933. Do you think that's even close to being right? Let's tab over here. Let's go over here. It's bigger than part 1, so is it right? Does circle get the square? Oh, thank goodness. Thank goodness. All right, we're done with 16. Return to my advent calendar. There it is. It's all filled in now. This is a terrible solution because of how long it took. 5 minutes, sorry, over 5 minutes to solve that one. Wow. And that was a release build. Not going to run that again. All right. Git status. Git diff. What did we change? I put that code in. I fixed the bug. This was the bug, and I just modified that comment because I was looking for something to do, and then I changed that to 26, and I pulled this out and put it here instead. Okay, so some minor changes, but we got 16 done. Git commit -am 2022 day 16 part 2 done finally. Sheesh. Git push. Okay.